Welcome to Biota.org Interviews. Today, the third part of the interview with Steve Grand. Steve, how are you?
Hi Tom, I'm fine, thanks. How are you?
Pretty good. Now, noticeably absent in our previous two conversations is any discussion with regards to neural networks. Did you do any tinkering with neural networks prior to Creatures?
Yeah, probably 1978 was the first time I tried to write neural networks. I heard some mention of them in a book, but I didn't actually know what they were, so I had to make it up for myself. And the ones I did were very different from the conventional three-layer neural networks. I can't remember much about them now, but they were messy and complicated and dynamical with lots of feedback in them. They didn't do anything, they failed miserably, but I kind of experimented with them from that point onwards.
Were they analogous to your previous discussion?
I think probably the first ones I did were digital, but it's a very vague memory. I mean, 1978 is an awful long time ago, but I pretty quickly went on to analog networks, and I remember evolving some neural networks in the mid-80s, very simple, unstructured networks, kind of stuff that was going on in labs in the mid-90s. But yeah, I went in for analog stuff pretty quickly, because neurons in the brain are, despite producing spikes, are pretty analog devices.
Now, you mentioned previously in the discussion with regards to Creatures that when Creatures actually came about, when it came to some kind of reality, you went away for a couple of days and had a good think about the neural networks that would go in Creatures?
I decided I was going to use a neural network partly to spice it up and make the behavior of the creatures more interesting and more lifelike. But then I had to come up with an idea for how to make them work. And conventional neural networks simply don't work in that kind of an environment where you've got a system that has to learn over long periods of time and live in a messy, complex world that runs in real time. So I went and sat on a hilltop for 3 days and thought about it. Mostly I stared into space with no idea how to think about the problem until it suddenly hit me that I should start to think about what the brain of a creature might look like if it was already perfect, if it had already learned everything it was ever going to learn from life. And once I started thinking about what the end result should look like, I started to think up ideas for how it could get to that point, and so how the learning could take place.
In terms of the breadth of the Creatures code, how much of it was actually the neural network code?
That's a good question. A sizable chunk, because they're quite complex neural networks in several ways. For a start, they're genetically encoded, so you've got all the code for actually producing the network from the genes, and then the neurons themselves are generalized and need to be configured. There's several twiddly bits in the way the dendrites, the synapses of the network are formed and so on, that as far as I know is still novel. So there's quite a lot of code involved. I wouldn't like to guess a percentage, but it was, a few thousand lines of code probably.
And in terms of testing and simulation, how much work did you put into the neural network in Creatures?
To some extent they worked first time, which was a big surprise to me. So I managed to think it through quite well before I even implemented it. As I remember, I rewrote Creatures 3 times, the whole thing. It started off as a DOS program, then became a Windows 95 program, then became whatever it was at the end of it. Olay came in and DDE and went out and all sorts of stuff. So I rewrote the whole code 3 times, and the neural networks kind of progressed. I think genetics was probably the last thing that came in.
I was meaning to ask in the Creatures-related interview, but did you do all the graphics to Creatures initially yourself?
I did some scratch graphics, yeah. I mean, in those days, the coder you generally did some graphics enough to be able to show the system working, and then a proper artist threw them out and replaced them with good stuff, and that's what happened to Creatures. So my first Norns actually looked more like chickens than anything else. I remember making a cardboard cutout and sticking pins through the joints and trying to find out how to arrange the joints of the creature so that they'd articulate properly. And I just like chickens for some reason. There's something about the way chickens' legs move that I thought was quite attractive. But eventually a proper artist got involved, and by the end of the project there were several.
You moved your neural network musing into actual hardware, into robotics. Can you describe that transition between developing it in software and moving it into robotics?
Well, the neural networks that I work with now are still in software, but they now connect to a robot instead of the simulation. There's several things to talk about there. I guess the reason I used a robot, well, there's several reasons I used a robot in later research, mostly because I was interested in perception and creating realistic simulations with ray tracing and realistic physics and sound and all the other stuff is just too hard. Whereas if you build a robot, you get all that for free. So it was a kind of a trade-off. There came a point where it was easier to build a robot and get the world for free than it was to create a virtual world.
Was it all one robot all the way along, or were there predecessors to Lucy?
Lucy was my first proper robot. First time I built anything you'd actually describe as a complete robot. There was intended to be several instances of Lucy, but they were all Lucy, if you see what I mean. You know, like a baby growing up. I was going to progress the design, rebuild the hardware as I got more money and more resources and more skill and more knowledge, and the software should grow up with her. In the event, there was Lucy Mark 1 and several bits of Lucy Mark 2. Well, I hadn't even finished Lucy Mark 2 yet.
So can you describe the transition into moving into robotics from developing exclusively in software?
But I suppose you have to talk about the reason why I carried on the research, what I was interested in after Creatures. The Creatures neural network was interesting, and it worked quite well, but it was all wrong. I knew before I even started that brains are not remotely like the networking creatures. I used to have to stand up and defend creatures to people, and people used to ask me whether I thought these creatures were really alive. And I'd say yes, because I like to wind people up and cause debate, and I thought it was a reasonable position to hold, that the creatures were actually living things at some level. And then they'd ask me whether they were conscious or not, and I'd say definitely not. But for a while I was saying that without really knowing why I was so sure. And eventually I realized that it was because the little creatures in the game had no sense of imagination. They had no internal model of the world that they could think with and predict the future with. They couldn't have fear in a realistic sense, because fear involves making a model of what you think is going to happen next and then worrying about it. And imagination seems to be the root of consciousness. Consciousness exists in this virtual world inside our heads. So that got me really interested in consciousness and imagination. And that's what Lucy is there for me to understand, is the imagination.
So in terms of developing the neural networks from Creatures to the neural networks in Lucy, how did you add these components?
Well, you don't add them, you throw away everything you thought was true about neural networks and everything people tell you about the brain, and you start again. Neural networks in Creatures, like most neural networks, feed forward. They involve data coming in through the senses, being churned around inside the simulated neurons and thrown out at the end as motor actions. And that feed-forward principle seems to be a common theme in AI and even in neuroscience. But if you think about a machine that can imagine things, there has to be data flowing the other way, from inside the brain back towards the senses. When we visualize an object, we use our visual cortex. You know, when we imagine a visual object, we use our visual cortex to compute the appearance of it. So we're actually sending data backwards through the brain towards the senses when we're imagining things. So that implies a network with information flowing in both directions, which is very unlike most networks. So I more or less started from scratch. I started with some questions about what we can and can't imagine, and worked up from there, and it all got a bit complicated.
So in terms of these metrics that you've described, of things like imagination and feed backwards as well as forward, how far did you get with Lucy?
Well, she can recognize bananas. Her biggest achievement in life is recognizing bananas, which is a bit of a sidetrack, really, because I'm trying to understand perception, because perception is part of imagination. We were using the same kind of circuitry to perceive the world outside as we use to generate an internal model of the world. And the most characteristic thing about perception, the most odd thing about perception, is that it's invariant. If you look at vision, when we see a banana, it just looks banana-shaped to us, whereas the actual pattern of yellow dots on our retinas changes from moment to moment as the banana's rotated or moved from side to side or seen end on or brought towards you and moved away. So scale, translation and rotation dramatically change the pattern of sensory data. And yet bananas still look banana-shaped to us. We can even recognize a banana if you cut it up in slices or peel it from both ends. And so there's something really weird about that. You actually find that invariance, the ability to recognize something completely independently of where it is, how big it is, and what way around it is. Applies to touch as well, and hearing, and lots of other senses, probably all senses. So I got absorbed in trying to understand that principle. What on earth is going on? Because most attempts to make perceptual systems in computers don't handle invariance. We use character recognition to read checks and handwriting from forms and so on. And it works fine as long as the letters are more or less the right way up and in more or less the center of the box. But if you turn the letter on its side or move it to one corner of the box, the system can't recognize it anymore. So most of our artificial perceptual systems are not invariant. But if you're trying to understand the brain, since that's such a characteristic feature, you really need need to understand how it works. So I got sucked into trying to understand how it works, and that's where the banana recognition came from.
But could it ever get to the stage where Lucy became so transfixed with bananas that she started dreaming in bananas?
In some senses, she was dreaming of bananas, yeah, but not as much as I would have liked. And that's an important point, and my main theme is trying to understand imagination, that ability to generate mental images and manipulate them in your head. And although I came up with a scheme that could recognize bananas from any angle and distance, it doesn't really show enough of those characteristics to satisfy me, so I kind of lost track a little. There are certain things about this invariance that really interested me, about coordinate transforms, and it's a bit complicated. But I really wish that I'd managed to get the imagination thing showing up a bit more. It wasn't really there in my first model, and that's something that I'll have to worry about in the future. It shows I was on the wrong track to some extent.
Now, you've talked a little bit about Lucy 2. Is she going to dream of bananas?
Now that's another side track. Lucy 2. Lucy 1 was a pile of junk. Built her over a weekend, more or less, out of bits of aluminium that I'd bought in the local hardware store and cheap electronics. And then I built 5 little computer boards to go inside her, and it was very, very primitive. Very sloppy engineering. I'm not very good as an engineer. And so it wasn't a very good hardware platform. The cameras were low resolution and clunky, and the muscles, even though I put a lot of effort into them, were very twitchy. And it's very hard to be intelligent when your body is useless. This is one of the problems with AI research in general. People make robots that have got 2 wheels and a bump sensor on the front, and then wonder why they can't make them intelligent. Well, how intelligent would you be if you were born with 2 wheels and a bump sensor on your front? You know, you have to have powerful senses and powerful motor systems before you can be intelligent. And Lucy Mark 1, she just didn't have the capacity to do that. So I decided to build myself a new robot, and I got some funding for the first time in my life, and set 2 to build Lucy Mark 2, but it turned out to be a lot bigger problem than I had thought, and I got absorbed in the problem of muscles, and that kept me occupied for a year or more, and I never really came up with a good solution to the muscle problem. So Lucy Mark 2 is, let's say, on the back burner.
So if she's on the back burner, what are you working on currently?
I'm writing a game again. It's a good thing you mentioned that. Yeah, I got sidetracked. I ran out of money for Lucy Mark 2. I mean, it was lovely to be funded for a while, but when the funding runs out, suddenly you find yourself with no work, and I couldn't find any more money to carry on with robotics. So I got involved in a project to make a virtual ecosystem for use in school, a 3D ecosystem. And unfortunately, that didn't raise any money either, and the project fell apart. But because I'd written an awful lot of 3D simulation code by this time, I decided to turn it into a game. So for the last few years, I've been working on a game that's currently called Symbiosis, and it's an artificial life simulator. But I don't want to go into too much detail about it just yet, because I'm not entirely clear how it's going to turn out myself.
Well, there's a running joke in artificial life that it's a $0 billion a year enterprise. So I think this is a shared theme. In terms of where you are currently, you've recently changed location. Is this a philosophical reawakening in some regard?
Well, it's a new opportunity, I suppose. A new country, new circumstances. Will kick my brain into action, maybe. Things have got a little bit stale up to press. Yeah, I'm hoping for some new ideas and new directions. But it's early days yet. Moving is a complicated and long business.
And for the podcast audience, you're currently speaking to me from Louisiana. Is the area affected by the kind of remnants of Katrina at all?
Yes, it seems to be. I mean, this is not my area. You know, I don't know the place very well, but yes, there is an awful lot of evacuees still around, and it certainly seems to have an impact. I mean, the subject comes up more or less every day in someone's conversation.
So this is, on a number of levels, a complete relocation for you. What is your sense with regards to how this will affect your development?
Who knows? Who knows? The trouble with this kind of game is that it's all about creativity and having new ideas, and the trouble is none of us know where new ideas come from, really. They just turn up, and so you can't really make predictions about what's going to happen next. But there are things you can do to make new ideas happen more often, and to kick up the backside, and a sudden change in your life is one of those things. So I'm keeping my fingers crossed for some great new insight.
We've talked a bit about this through the previous 2 interviews, but what more would you like to see with the artificial life community?
Well, it would would be nice to see it come back into existence again. I don't know. I mean, I've kind of moved away from artificial life in its purest sense, and maybe now that biochemistry is taking over artificial life and doing it in hardware instead of software, life itself is about to change. But my interest has always been in biologically inspired AI, so taking an artificial life approach to the problem, and that's still as valid as ever, because we still don't have a clue how the brain works, we still don't have a clue how to make bottom-up intelligent systems. Who knows?
Where do you think the insights could come from? I mean, you've touched on a number of different areas. You've touched on robotics, you've touched on neural networks, you've touched on analog systems and various other things. You've seen game development, you've seen academic research. I mean, from all this experience, what insight can you give?
The answers lie in neuroscience. I think the insights that we, first of all, didn't look for and now wish we had lie in neuroscience, understanding the brain. The problem is that neuroscience is rather bogged down in its own ideology and needs a bit of a kick up the backside itself. So I think probably the future lies in computational neuroscience, in using computer models to simulate real biological systems, but looking for the engineering principles that are at work. This is why I find artificial life interesting, because I've always been interested in biology, but biology is really obsessed with the details. How did this particular organism evolve in this particular environment on Earth? And real biology is horribly messy. And artificial life's nice because it looks for principles. It uses computer simulations to try and find out what the basic ideas are that lie behind life. And I think there's a need for the same kind of thinking in neuroscience, that instead of modelling precise details of neural systems, we should be looking for the engineering principles involved. And a lot of people are, but there's plenty more scope in that direction. So I think the place to look for the future is computational neuroscience, using computer models to simulate complex neural systems. But I wouldn't bet any huge amount of money on when that's going to make changes.
Well, I've got to thank you very much for the opportunity not to interview you once, twice, but to interview you 3 times, Steve Grant.
Oh, you're welcome, Tom. You can come back and do me a 4th time when I've had some new ideas, but just leave it a decade, eh?
Be sure to let me know.
I will.